In this lecture, we'll see make use of triggers. When you go to Adafruit IO, you open triggers. We already created two dashboards, project 3 dashboard and project 2 dashboard, right? Where it displays some vibration data. Let's go to dashboards. There here, you'll find triggers. Now, I want to create a trigger. What is the trigger is? If suppose you're receiving some sensor data, based on sensor data, you want to do a decision. This is what we call as trigger. Now, I want to create a reactive trigger where my trigger feed is my vibration data. And if the vibration data is greater than, you can have multiple options, greater than, less than, or less than, equal to, greater than, or equal to, like that. I want to give a comparison feed value. Every time my vibration data will be 0. If some event happens, it will be improving more than 2 or 3. So I'll just put it 3. Now what is my action for that? My action for that is to publish a message. And I will publish a message to GPIO 16 saying that it should be on when my vibration is greater than 3. I'll just create it. Now, one more action I'll create, trigger I'll create, again a reactive trigger. The trigger feed is again vibration data, and the comparison is if it is less than 1, this is the minimum value it can have, then I'll send a message. I'll publish a message saying GPIO 16 to be off. Okay, I just created these two triggers now. Now, what I shall do is, I'll go back to the code. Now you have two projects. In one project, you are actually sending temperature, humidity sensor data. Let the project be same, flash it in one board. And we have one more project where we were sending our trigger data, GPIO 2 or GPIO 16. We were trying to control the GPIOs from the Adafruit. Now these are two projects. What I have done is, I have flashed one project in one board and another project in another board. Now let us say these two boards are away from each other, like they are been in two different locations and no way connected between each other. Now the action which is happening at one board has to control actions which will happen at other board. In a sense, I'll just open Adafruit. Now you see there is a dashboard. Now in project 2, you are getting vibration data. Here I am not getting any data now. I did not connect the network. I'll be getting some data. Let's say if my vibration data is greater than 1 or 2, then what should happen? The devices which are connected to in this dashboard should get triggered. That's what I made. Now you have the same common code. This particular code where it is trying to send vibration data and humidity data to the Adafruit. Now after these have been received by Adafruit, I have put a trigger action that this particular GPIOs which are connected to another board, which are reading messages, this is the code which is running in another board, should do the action of enabling or disabling the GPIOs based on the message received. So how to send the message, or like when to send the message, the trigger action or the trigger event is being done at Adafruit. Now this MQTT broker is actually doing it. You are not making any decision. This is completely automated. Now we shall move to the demo. The code is nothing different. Everything is same. One particular change I have done is, when I am sending temperature and humidity data, I have increased the interval to 7. If you don't increase the interval to 7, there is a chance that, as you know, you are subscribed to Adafruit IO free subscription, where I have limited data points, like 30 data points only I will be able to send. So if I increase it more, anyways my data feed from trigger is also coming. So these will multiply. You will receive 30 data points already from temperature and humidity sensor along with the trigger data. So this data will increase, so which will cause problem with Adafruit. It will not allow you to send any data packets further or receive any data packet further. So in order to avoid that, I have increased my feed interval measurement interval to 7, so that for every 7 seconds the data will be sent. Now what I will do is, we'll go to demo. I'll show you what is happening with the demo. So simply in the demo, it should be evident that upon a vibration event happening on one device should affect the GPIO on the other device. This is what we want to do. Let us have a look at the demo.